Hi, great minds. Welcome back to Organotope Chem Clinic, where chemistry becomes crystal clear. In this video lesson, we are going to be discussing one of the coolest topics in organic chemistry, which is IUPAC nomenclature of aromatic hydrocarbons. If benzene, toluene, or phenol ever confused you, stay tuned. I will make it crystal clear in minutes. What are aromatic hydrocarbons? Aromatic hydrocarbons are organic compounds that contains one or more benzene ring in their structure. So from this definition, we can deduce that benzene is the parent structure in all aromatic hydrocarbons or compounds. Can we consider the parent structure, which is the benzene ring? It contains 6 carbon atoms connected or joined together by alternating double, single, double bond. So we have carbon connected with another carbon. We have this, just like a cyclohexane structure. Okay, so we've been able to connect the carbon atom right here. We have 6 carbon atoms in this structure, so we are going to connect them with alternating double, single, double bond. Okay, so we have a double bond right here. The next one will be single bond, double, single bond, double bond. So we've been able to come up with alternating double, single, double bond. So the next thing we need to consider is the tetravalency of carbon. Carbon is tetravalent, that is, you can have just 4 bonds to carbon. If we are to come up with the structure of any organic compound, we must take note of the tetravalency of carbon. Therefore, I need to complete it with 1 hydrogen atom, hydrogen atom, hydrogen atom, hydrogen. Can we check the bond around this carbon? 1, 2, 3, 4. So we have 4 bonds around the carbon already. So we are reflecting on the tetravalency of carbon. Okay, carbon is tetravalent, that is 4 bonds. Tetravalent, we have 4 bonds around every carbon in an organic compound. Make sense? So this structure is a benzene structure. So I have it as what? Benzene. And note that benzene is aromatic hydrocarbon. Aromatic hydrocarbon are stable but contains what? Unsaturated bond. So we can equally say that they are highly unsaturated cyclic compound. So can we deduce the molecular formula of this benzene structure right here? We have 6 carbon in the ring. We have C6. How many hydrogen atoms are there in the structure? 1, 2, 3, 4, 5, 6. We have 6 hydrogen atoms. Therefore, we have it as what? H6. The molecular formula of a benzene is C6H6. We can as well rewrite the benzene structure in this form, provided we consider the alternating double, single, double bond within the 6 carbon atom of the benzene. We have carbon connecting to another carbon, all through with a single bond at first. Then here we have double bond. I can have it as a single bond right here. Then the single bond becomes double, double, single, single becomes double, double, single, single becomes double. Okay, so I've been able to express the alternating double, single, double bond in this ring as well. So we saturate it with hydrogen atom, okay, to make what? Tetravalency of carbon. So we've been able to balance up the tetravalency of carbon atom right here. So this structure of the benzene is equally the same thing as this one right here. When we get to calculate structure of benzene, we'll discuss this further. Since it has been observed that in both structures, the double bond can revolve around the 6 carbon atom of the benzene. Therefore, for conveniency, we can also write the structure of benzene in this way. We have it as the hexagon that contains a circle at the middle of the structure. So this is also a benzene structure. So we have this as benzene as well. But for conveniency, we can write our benzene in this form. So it is easier to write the structure of benzene this way. Moving on, other examples of aromatic hydrocarbons include the naphthalene and the anthracene. The naphthalene contains 2 fused benzenoid structure, while the anthracene contains 3 fused benzenoid structure. They are regarded as polyaromatic hydrocarbons because they contain more than 1 benzenoid structure. Can we identify the naphthalene and the anthracene right here on the board? Now let's deduce the structure of the naphthalene and the anthracene. We have 2 fused benzenoid structure for the naphthalene. This is cyclohexane ring fused together. Okay, so we are going to express the alternating double, single, double, single, double bond right here, and we have the double, single, double bond. So there is a double bond here, so we are not going to include another double bond on this side. So right now we have what? Our naphthalene. Naphthalene. Okay, so we have 2 fused benzenoid structure in naphthalene. Can we express that of anthracene, where we have 3 fused benzenoid structure? We have a cyclohexane structure fused with another cyclohexane structure, and we have another cyclohexane structure. Okay, so the next thing is to indicate the position of the multiple bond, our double bond. So you are expected to start from here: double, single, double, single, double. Okay, so you move to the next ring: double bond, single bond, double bond, and you move to the third ring: double bond, single bond, double bond. So we are not expected to express the double bond right here because this double bond right here also affects this position. Okay, so we have a 3 fused benzenoid structure, which is what? Yes, anthracene. We have anthracene. Okay, here is the structure of anthracene. Therefore, naphthalene and anthracene are regarded as polyaromatic hydrocarbons. Make sense?